Hi Kim. Today we are doing a little bit of notes on section 10.9, which is kind of like a recap of all the kind of conversions that we've done so far regarding the mole. So the unit mole is very useful because it kind of serves as a central hub or like a central road you can kind of think of, or highway system for all conversions. So again, if we want to go like from mass to atoms, we can do that. But remember, there's no direct road or path that way. We have to go through mole. So chemists really use the mole as like a central measurement. And we use the mole when it comes to concentrations as well, which we haven't gotten to yet. But it's a very important unit in chemistry. So if we can convert to the mole, we can basically convert to any other unit that counts something. So we can do volume, mass, number of atoms, number of molecules, number of formula units, which remember are like molecules for ionic compounds, and number of ions. So we've already made a roadmap in class that looks something like this, where we have mole in the center, mass in grams, number of molecules, and number of atoms, and every little speech bubble here has a little conversion factor in it to go between those. So this is the central roadmap that we've been using in class so far. When we first started this remote learning, I also started to add the concept of being able to convert to volume using the mole. So we're going to go ahead and add that to our roadmap. So if you have your roadmap out, you can definitely add to that. If you need to start a new copy because you lost yours or something, now would be a great time to do that, because remember, on your quiz on Thursday, I am letting you use that roadmap. So we can also have our conversion going from moles to gas volume. And it is only volume for gases, it's not volume for liquids or solids. But we could add that up here. And I kind of took out other conversion factors just so it didn't look so messy. But we can go from mole to gas volume, which is measured in liters, through a conversion factor of molar volume, which is 22.4 liters over 1 mole. So that's how we go from mole to volume. We would multiply the number of moles that we have. So if we had 3, we would multiply 3 by 22.4 and divide by 1. Our mole unit would cancel out and we would get liters. Or we could go the other way. So we have 2 liters of O2 gas. We could take that 2, multiply it by 1, divide it by 22.4 liters. Liters would cancel out and we would get our value of moles. Okay, from moles, again, we could go to molecules, then atoms, to figure out how many atoms of oxygen are in 2 liters of O2 gas. But we have to take these roads, which are kind of like the arrows. We can't take any other road. And again, if we have something that's not it's not on the periodic table, it's not a pure element, then we have to go through molecules to atoms. So for O2 gas, since it doesn't exist as just an atom, O2 is a molecule, we have to go through here. So I kind of compare that to like the carpool lane. You can only go in this lane if you have a carpool, which in this case, you can only go in this lane if you are an atom, a single atom, or a single element. But that gets confusing because O2 is a single element, but it exists as molecules, so we have to go through there. So if you're confused on that, please let me know. So go ahead, you can add this conversion if you haven't already to your roadmap. And again, if you need to make a new roadmap, that's totally fine as well. But I want you to have a hard copy that you can use on your quiz on Thursday. ck12, the online program we've been using in section 10.9, uses a roadmap that looks like this. So they have volume, mass, and then they clumped atoms and molecules, formula units, ions, all those things into representative particles because those have the same conversions. I added atoms into it because you can go to molecules using this conversion, but I wanted you to be able to also have a road that showed you how to go from molecules to atoms. So that's why my roadmap has an extra road for you to use. But it is the same general idea, and this kind of shows you that. If you read the ck12, they will reference kind of this roadmap, and again, that's fine. but you can definitely use the roadmap that we've used in class to kind of solve these problems as well. So we do have a sample problem. What is the volume of 79.3 grams of neon gas at standard temperature and pressure? Remember, this STP is important because without STP, we couldn't use this molar conversion. So that's why the STP is important here. So step one, we have to list our knowns and our unknowns. So we know the molar mass of neon is 20.18 grams per mole. We know that from the periodic table. We also know our molar conversion is 1 mole is in 22.4 liters for any given gas at standard temperature and pressure. We also have our given, I didn't list that down here, but our given is also that we have a mass of 79.3 grams of neon gas. What we're looking for overall is our volume, which is going to be in liters. So now that we have our knowns and unknowns, we can go ahead and calculate. So we're going to be starting with the known as 79.3 grams. From grams, we can't go directly to volume. So if you look at your roadmap, there's only really one road that you can take from grams, and that is going to moles. So we are going to go ahead and convert from grams to moles. If you look at your roadmap, the conversion factor that we're going to use for that is 1 mole over the molar mass, okay, which is really the molar mass here, just inverted. So we're going to take 79.3, multiply it by 1 mole, and divide by 20.18. That's our first conversion. This needs to get out of my way. Is there a way to like move it? Nope. Oh well, I'll just wait for it to disappear. So that is our first conversion. So from here, we're going to cancel out grams, and that gives us moles. Can we go from moles to volume? Absolutely, because the mole is the hub, the central of all of our conversions. So we can go ahead and use our STP molar volume, multiply by 22.4 liters over 1 mole. Remember, we have moles in the numerator, so to cancel it out, we need moles in the denominator. So that's why I chose that conversion factor. Also on the roadmap, that's the conversion factor that's listed for that road. So here, again, our grams are going to cancel out from that first conversion factor. Moles are going to cancel out in our second conversion factor. So now I can take this 79.3 grams, multiply by 1 mole, divide by 20.18 grams, multiply by 22.4 liters, divide by 1 mole, and my calculator should put out 88.0 liters of neon. So for review for these sections, again, I won't necessarily answer the question, just try to kind of lead you to the answers. So in the problem above, the problem that we just did was the formula weight of neon. Formula weight in this case is the same as the atomic weight or atomic mass, because formula weight refers to the weight of the whole chemical formula. So for like water, H2O, it would be the sum of all of those. For neon, it's just neon, since neon is a pure element on the periodic table. Remember that atomic mass and molar mass, they have the same numerical value, so they have the same number. But what unit is the atomic mass or the formula weight going to be in? Is it going to be in grams, or is it going to be in AMU? The second question, what value is at the center of all the calculations? What's the center of our roadmap? The hub. Pretty obvious, I think, at this point. And then the next question, if we had 79.3 grams of xenon, that's Xe, would we expect a volume that is greater than or less than that obtained with neon? So that's referring again to the question that we just went through. So if we instead had 79.3 grams of xenon, would it have the same volume, a greater volume, or a smaller volume than the answer we got in the previous problem, which is 88.0 liters? So for that, you could just compare the molar masses of them between the two and see how that would affect what you expect. And then you could also just plug in, instead of the molar mass of neon in the previous problem, you would plug in the molar mass of xenon and then see what value you get. Is it greater than 88 or is it less than 88? those are all the notes I have for this section. You will go ahead and do the ck12 sections again for this 10.9. That is going to be due tomorrow at 4 p.m. I know yesterday, especially in period 4, beginning of period 5, we had issues with the ck12 not loading very well. I think it's just a matter of the website being overrun because a lot of schools are now doing online learning. So try to be patient if it's not turning in for you. Just try again in an hour, 2 hours, 3 p.m., something like that. So just try to get it turned in before 4 p.m. tomorrow. You might have to try multiple times before it lets you turn it in because, again, it is very busy. Same thing with Edpuzzle. If your Edpuzzle is not loading, let me know. I'll just send you the direct YouTube link because we had that problem in 6th and 7th periods. So we had 2 different technical problems in different periods yesterday, which was a lot of fun. But hopefully the websites are able to take care of it. So again, let me know if you have any questions, and